Hello everyone, welcome to iPADS Statistics. Today's lecture has been suddenly produced with an AI voice. That said, I probably cannot make every lecture in AI audio. When that happens, please bear with my clumsy English. Today's topic is Chapter 3, the R environment. Let's start by installing R in RStudio. This is the RStudio graphical interface. It's basically a 4-pane layout, so a large screen makes life easier. If you're wealthy, feel free to buy a huge monitor. My recommendation is a BenQ monitor. For a very scientific reason, it's inexpensive. You can download R from the official website. It works on Mac OS, Windows, and Linux. Please download RStudio as well. These days, more people run R in the cloud using POSIT Cloud, so the website may look a little different. In this course, we install and use R plus RStudio locally, desktop version. Of course, the code for this class also runs fine on POSIT Cloud. Here is RStudio's start screen. From top left going clockwise, we have the source code pane, the console, the environment history pane, and the files, plots, packages, help pane. Again, 4 panes. So on my small laptop, everything feels petite. Let's begin with the 2 panes on the left, the source and the console. In the red source pane, click Run to execute your code. In the blue console pane, you see what happened. In the console, blue text is the code that was executed. Black text shows the results. For example, tables, t-tests, or regression outputs. Red text indicates an error when your code isn't quite right. Pro tip: if you copy your code together with the red error message into ChatGPT, it will often suggest a fixed version. Now for the panes on the right, environment, history and files, plots, packages, help. In the green environment tab, this is where objects and imported data live. In the history tab, every command you have run so far gets stored here. In the yellow files, plots, packages, help pane. Files, browse files on your computer. Plots, graphs appear here. Packages, install and view libraries. Help, search documentation to learn how functions work. A bit more on the files, plots, packages, help pane. It's surprisingly important. From files, you can check your folders. On POSIT Cloud, you'll see your cloud files here as well. Packages shows what's installed and lets you install more. When you make a figure, it pops up in plots, and if you get stuck, check help. You can ask ChatGPT too, but help is free, so even if you have debts like me, it's budget-friendly. What are packages? R in its initial state is pretty lean. It cannot do fancy graphics or specialized analyses out of the box. That power comes from packages. Add-on libraries contributed by the R community, universities, labs, companies, and many volunteer researchers. For example, install dot packages, t.idYVERSE, and R will download and install the tidyverse meta package, which brings in core packages such as ggplot2, Doppler, tidyr, readyr, purr, tibble, stringer, and forcats. Installation alone does not make a package active. Each time you start R, you must attach the package library, tidyrseve. Think of it like a card game. Installing puts the card in the deck. Library is the moment you draw it into your hand. Finding methods and packages. If you search reputable R resources, you will quickly find packages that match a method. Regression, mixed models, spatial analysis, you name it. A good habit is to search R plus method, name plus package. Where to ask questions. You can also ask questions on community Q&A sites. With luck, a kind soul answers before your coffee gets cold. Be specific. Include your code, error message, and a tiny reproducible example. Using AI effectively and fairly. These days, using AI to write code and clean data can save a lot of time. Please leverage generative AI to boost your productivity. However, if an assignment is marked your own answer, submitting a response entirely generated by AI from idea to final text may significantly reduce your score. Use AI as an assistant. Keep the thinking and justification yours. First, set a working directory. The working directory is simply the folder R is currently looking at. If your data live there, life is smoother. Create a course folder on your computer, for example, student data. Put your files inside, and at the start of each session, tell R to work there. How to set your working directory, example path. Suppose you have documents/data/R book examples. You can write set WD where C documents data R book examples. Tip: in Windows paths, R likes forward slashes or double backslashes, RT. Windows case, step by step. Download student data from Google Drive. Unzip student data. Move the student data folder somewhere easy to find. In File Explorer, Shift plus right-click the folder and choose Copy as Path. Paste it into your R script, Control-V. You might get something like C/users // downloads / for students / student data. Replace / with slash or escape them as // C /users / downloads / for students / student data. In your script, set working directory to C /users / downloads / for students / student data. Click Run. If nothing explodes, you did great. Bonus, RStudio projects avoid CTWD entirely and are even friendlier, but CTWD is fine for today. Mac case, step by step. Download student data from Google Drive. Unzip student data. Put the folder somewhere easy to find. In Find or Hold option, then right-click the folder and choose Copy as path name. Paste into your script, Command+V. You might see /users / downloads / student data then. Set TWD /users / downloads / student data. Check your working directory and read a file. You can confirm your current working directory with get. If your data file cats.dat is inside that folder, this will work. My data read.delim.cats.dat. By the way, anything after number sign is ignored by R. Use it for notes and remarks. That's the basic flow. Install, attach, set your folder, and read your data. From here on, we analyze like ninjas. Quiet, precise, and occasionally dramatic. Now we can read files directly from that folder. For example, my data, read.delim, cats.dat. My data 2, read.delim, examanxiety.dat. If those run without errors, you should see My Data and My Data 2 appear in the Environment tab top right. If not, R is just testing your patience. Check the working directory and file names. Installing packages from the GUI. You can also install packages from the Files, Plots, Packages Help pane. Bottom right. Open Packages, click Install, type the package name, and proceed. It's perfect when your fingers need a break from typing. Let's create our own data. Of course, you can import Excel or CSV files into R. However, to work with real survey data, you often need to build or reshape your own datasets. In R, common data types include numeric, numbers you calculate with EREG 3.14, 42, -7. Character or string, text like Apple or Tokyo, great for names, IDs, and labels. Factor, a categorical variable with a fixed set of levels, e.g. male, female, other. internally stored as integers with labels, essential for categories in modeling and plotting. Date, calendar dates like 2025-11-03. R knows how to compare and sort them in time. Creating a string variable, we use C to combine values into a vector name. C, Ben, Martin, Andy. Quotation marks tell these are character values. Creating a date variable, DOB, as date, C, 1977-07-03, 1969-05-24. Each date was typed as a string, but as a date converts them into real date objects. Now R can sort and subtract dates. Creating a coding variable and turning it into a factor. Suppose our sample has 5 lecturers and 5 students. Enter the data like job, C rep 15, rep 2, 5, 5 job, factor job levels 1 to 2 labels. Lecturer student, now job prints with labels instead of mysterious numbers. Great for models and plots. Creating numeric variables. Numeric variables are the easiest. Friends, C5, 2, 0, 1. Alcohol, C10, 1, 15, 20, 5. Creating a data frame, bind everything together. Lecturer data, data.frame, name, DOB, job, friends, alcohol, income, neurotic. Lecturer data. If this prints a tidy table, congratulations, you just manufactured data. Economists do this all the time, just a joke. Importing data from a file. If your directory is set correctly, this will work. Lecturer data, read.lim, lecturer data.dat, header, exam, true, head lecturer data. If you get file not found, your working directory and the file's exact name, need a quick double check? Please don't forget spaces when you designate data name. Saving to CSV and reading it back. Write.csv left parenthesis lecturer data, right parenthesis, comma space, lecturer data.csv, comma space row, dot names equals false, lecturer data, 2 left parenthesis, less than, read.csv left parenthesis, lecturer data, and .cs right parenthesis, greater than head lecturer data 2. Round-tripping data is handy for sharing with friends, co-authors, or your future self. Saving and loading, CSV and stata. Let's save our data and read it back. Write.csv, lecturer data, lecturer data 3.csv, row.names equals false. Lecturer data 3, read.csv, lecturer data 3.csv, lecturer data 3. If you prefer a plain text table with a custom separator, you can do write.table, lecturer data 3.txt, CP, rejoined comma, row.names equal false. Lecturer data 3, read.table, lecturer data 3, .txt, SAP equals comma, header equals true, and for stata format, handy when collaborating. Install.packages, Haven, library Haven, write ddta lecturer data.dta. Note, the argument sep sets the field separator, that little character between columns, comma, tab, etc. Think of it as where one variable ends and the next begins. Selecting parts of a data frame, columns. Indexing syntax is new data, old data, rows, columns. Let's keep only 3 variables. Lecturer, personality, lecturer data, C, friends, alcohol, neurotic, lecturer personality. Selecting rows, cases. We can filter rows with a logical condition. Suppose we want only lecturers, lecture only. Lecturer data job equals lecturer, lecturer only. Selecting rows and columns together, let's grab the personality variables, but only for people who drink more than 10 units. Alcohol personality. Lecturer data, alcohol greater than 10. C, friends, alcohol. Neurotic, alcohol personality. Doing the same with subset. The subset function can be a bit friendlier to read. Alcohol personality. 2. Subset, lecturer data. Alcohol greater than 10. Select equals C, friends. Alcohol. Neurotic. Alcohol personality. 2. Data frames versus matrices. Why your code sometimes does nothing. Some functions in R were written to work only on matrices, not data frames. When that happens, convert first. Num only, lecturer data, C, friends, alcohol, income, neurotic. Num matrix, as dot matrix, num only. This type mismatch is a classic beginner hurdle in R. Unlike some software, R has many packages written by different authors. A few functions expect a specific data type. What's the actual difference? A matrix is a two-dimensional array with one data type for all entries. Practically, use it for numeric data. A data frame can mix types column by column, numeric, character, factor, date, etc. So if a function complains, check, does it want a numeric matrix? If yes, select the numeric columns and convert with as dot matrix first. Your future self will thank you.